All right, good evening, everyone, and welcome to our talk on the future of digital inking. This is Amni Reddy. She's a program manager here on the Input.ai team at Microsoft, and I'm Johan Puri. I'm a software engineer on the same team. Now, over the past few years, we've brought you inking experiences on UWP, on Win32, and this year, we brought you inking on XAML Islands as well. Now, over our journey here at Windows Ink, we focused on three big pillars. The first being quality. This involves our smoothing algorithms, our rendering algorithms, our input modeling, and making sure you have the lowest latency input possible. Then we focused on ease of use. We did this through our controls, such as Ink Canvas and Ink Toolbar, that you could drop into your native apps and give your customer an inking experience out of the box. And then we focused on extensibility. This involved using powerful APIs, such as on-strokes collected, on-core wet stroke update, to change what the ink looked like, both while rendering and post-rendering. But we know that you're building apps that are cross-platform, cross-device, maybe even exclusively on the web. And so we're excited to share with you what we're doing with Windows Ink in the future. Now, as a quick note, all of the work you're about to see is in progress. We're working really hard on being able to deliver this to you super soon. But today, we're looking for your feedback, we're looking for your comments, and most importantly, we're looking for your partnership. So let me touch on the quality aspect first. Windows Ink has grown tremendously over the past few years with constant tweaks and improvements to our rendering algorithms, our smoothing, to our input latency, and we wanted to bring all of that goodness over to the web. And with C++ and WebAssembly, we're doing exactly that. So you get the same quality, consistent experience that you've come to expect from Windows Ink. Let me give you a sneak peek on what I'm talking about. So on the screen is a simple side-by-side demo. On the left is our new WebAssembly-based ink rendering, and on the right is a traditional Canvas 2D. Now, a Canvas 2D is what most web developers would use in their apps if they wanted to bring in inking, and they didn't have a background in computer graphics. Notice the paper on the left. It's very representative of what real crumpled paper looks like. And that's because it is. I took a picture of real crumpled paper, threw it in GIMP, took out a normal map and a specular map, and threw that onto that web page. Now notice how the ink acts as I draw across this paper. The ink is reactive. It's dynamic. It reacts to the paper. It reacts to the creases on the paper. And now compare it to the ink on a Canvas 2D. Let me zoom in for you. The ink on the left is crisp and smooth, while the ink on the right has jaggies. Notice how the ink acts when I draw a little faster. When I draw faster, the ink is lighter. And when I draw slower, the ink is darker, similar to what you'd expect with an analog pen. Now, when we were working on this problem of quality, we asked ourselves how we wanted to deliver this experience to you, the developer, to make your lives easier. I'm going to head back into my presentation really quick. Now, on native code, it was just as simple as dropping in an ink canvas and an ink toolbar, and you had an inking experience. And on the web, it's going to be just as simple as dropping in an ink canvas and an ink toolbar into your HTML. We're building simple, reusable web components that you can bring into your Angular, your Vue, your React apps, or any other flavor of JavaScript you use. You will find support in either our ink library or our web components. And we want to show you a sneak peek of what this experience for a developer could be like. So I'm going to head over to Visual Studio. What you're looking at is a simple HTML page. This is an Angular app built in .NET Core. It's really basic. It's got a div, a header, 4 paragraph tags. And the text is from a Windows blog post earlier this year. Let me show you what the page looks like. It's just a simple page, not a lot to it, right? What if you, as a web developer, wanted to bring annotations to this page? You'd have to build some sort of canvas, subscribe to pointer events, make sure those pointer events work across every browser, and there are a lot out there. Then you'd have to, when the points come in, do some kind of point modeling, smooth them maybe into Beziers, and then render them onto a screen. That is a lot of work for a web developer to do. Watch how easy it is to achieve all of this with our web components. I'm just going to go over to my HTML, and under this header tag, I'm going to add an ink canvas. I'm going to close that tag. I'm going to first set its width to 100%. I'm going to set its height to 100%. I'm going to hit save. Can't be that easy, right? I'm going to watch that page refresh. My text is gone. And that's because there's an ink canvas sitting right in front of it. It's just that easy. But obviously, as a developer, you want to change how this canvas looks. And with CSS custom variables all across our code, you're going to be able to do exactly that. Let me show you a quick example. I'm going to change the background color custom variable. And I'm going to set it to transparent. I'm going to save that. I'm going to head back. It's going to refresh. And just like that, you have annotations on your web page. How easy is that? The best part is you can change what the ink looks like as well. This time, I'm going to head over to my TypeScript code. And I want to tell my web component what the ink should look like. So I'm going to create an object right here. Let's give it a type any for now, because it's just a demo. And I'm going to set a few keys on this object. So I'm going to set, here you go. Create a new object. And let me set, the first thing I'm going to set is a hex color. This is just the color of what I want the ink to be. Here is the hex code of a simple yellow. Say I want highlighting, so I'm going to set the opacity of this to, let's say, a 40%, so that's a 0.4. And then I'm going to set a width, let's say, to 20. Right? I'm going to say that. Now I need to tell my web component where to look for these properties in the ink. And this is really simple, because the web component has an attribute on it called ink drawing attributes. And if I just set that to my ink options, now I'm going to do some Angular binding magic here. Angular allows you to bind an object to something in a web component by just doing that. This will be different in the framework you use, but that doesn't matter. We will support a whole variety of frameworks, right? I'm going to hit save on that. I'm going to head back to my web page. It's going to refresh. And just like that, you have highlighting on your web page. Now, we at Microsoft truly believe that your ink should go far beyond what is possible with an analog pen. So we didn't stop there. And this is where our third focus of extensibility comes in. On native apps, you could use Powerful API to modify what the ink looked like. On the web, we're giving you even more power. Not only will you be able to extend these web components to build your own, but we're bringing you some out-of-the-box abilities that are super awesome. Check this out. This is it's a very simple web page. It's an ink canvas and an ink toolbar. And I want to show you that this is just 2 lines of HTML. So I'm going to head over into developer tools. I'm going to zoom out a little bit. And let me expand this for you. So check it out. It's just an ink canvas and an ink toolbar. There's nothing under it except for the shadow root of the web component. This is just a dropped-in canvas and toolbar. Into this canvas, as an attribute, I've passed it my ink recognizer cognitive service API key. Now, as a note, the cognitive service, the Ink Recognizer cognitive service, is in public preview starting build. You can go to the Azure Cognitive Services website to check it out. I'm going to hit Ink to Shape. I'm going to pick a color, and I'm going to draw in it. And that's it. Out of the box, Ink to Shape, by dropping in a web component. And the best part is, let me show you another demo that I think will resonate with you a little more. We all fill forms in our everyday lives. You go to the doctor's office and you fill out your patient history. You go to the DMV when you're applying for a new driver's license, and you fill out a form there. Or maybe you're an auto insurance inspector named Bob, and you've come to a site of a car incident. You need to fill out this form. It's a simple, traditional form. You brought your tablet along. Now, you could attach a hardware keyboard and type into those boxes, or you could work with a software keyboard, which can be cumbersome to type. But what if you could write directly into these text boxes? How cool is that? Oh, finish that A. There you go. One web component, one recognizer API key, and telling the Ink Recognizer which text box you're manipulating, and the Ink library and the Ink Recognizer service handle everything for you. And the best part is these boxes are smart. For example, the first two boxes here are scoped to being a full name and a phone number. The Ink Recognizer understands the context in which you're writing. Let me give you an example. The third box is scoped to be to get results from a predefined list of car manufacturers that we've given the box. So when I start writing something like, let's say, Subaru, it's going to look for the closest match it can find from that predefined list and give you a result based on that. You can choose from a multitude of scopes, from street addresses, URLs, to names and phone numbers, and your own custom lists. It's incredible. Let me show you another extended web component now that I think will resonate with you the most. I can't recall how many times I've been on a web page and I just need to sign at the end of it. Most recently when I filed my taxes, I just had to sign. And it's so difficult to do on the web today. Drop in one web component, sign on it, and with a simple API, you could pull off the PNG for the image. Just sign and commit. It's that easy. Now my colleague Avni is going to tell you about why we think the pen is so fundamental to what we do here at Microsoft, and why inking is at the core of our developer story. Avni.
Okay, just going to go back to our presentation here. Oh. Okay, so I want to take a step back and talk to you about why we continue to invest in the pen and ink at Microsoft and why we really care about it today. Now, just take a look at the examples on this screen here. The pen allows you to express yourself in a way that no other input can. You're not bound by the rigid confines of the typed word. You can do things like create the physics and math notes shown here, make a custom to-do list in your own personal style, draw sketches, and so on. And really, they're great examples of how the pen is a tool for creativity and expressiveness. However, we also believe it's a tool for productivity, especially when fused with AI. And that's what we want to talk to you about today. Now, we show this slide every year just to reiterate that we have compelling data that tells us that the pen and ink are important to our consumers. We see that the pen is second in purchase intent, higher than the switch to SSD, and even considerations of processor RAM and storage. We see that the market's doubling year over year, which is why we continue to invest in this space. And we're seeing that the pen is becoming a more ubiquitous form of input across other mainstream devices. We're seeing more and more pens cross-platform, such as the Pencil on Apple iOS or the Samsung Pen on Android. And even though we have more pens in the Windows ecosystem than any other, we're seeing more and more pens cross-platform, which is why it's important for you to understand how you can make the best pen and inking experiences in your applications. Now, when I think about the ink in the real world, 3 words really come to mind: personal, expressive, and natural. My writing and drawings are really personal to me. And you know, the free-form nature of pen and ink allows me to be expressive in a way that no other input can. And of course, it's natural. Humans have been writing and drawing for millennia. But now, if all we did was replicate the same experience that you get on analog pen and paper today, we wouldn't truly be embracing all of what digital ink has to offer. And this is where intelligence comes in, and how we make digital ink truly shine. An example of this intelligence is our ink recognizer cognitive service, as Johan showed you in the whiteboard demo and the form filling demo earlier. It allows you to consolidate your recognition logic across your UWP, Win32, or web application and hit our cloud endpoint. Now, we do a number of different techniques to our ink on the screen before actually recognizing it at the end of the day, to provide you more contextualized information about what the ink is on your screen. First, we start with something called ink classification, where we divide up into 2 groups what your ink is. They're writing regions and drawing regions. So if you look at this example on the left-hand side here, you see that all of the shapes there would be drawing regions, and all of the text would be a writing region. And then we go into our recognition pipelines. Now, we recognize a core set of polygons today for our shapes. Before we actually recognize our text, we do something called layout analysis, where we actually look to see which words make up lines and which lines make up paragraphs. This helps you do things like do selection and conversion logic in your applications. And lastly, of course, we recognize your words on the screen. And not only that, we can provide up to 10 alternate candidates for each word. Now, the Ink Recognizer Cognitive Service is available in public preview today. If you go to the Azure Cognitive Service website, you can learn more about it. Now, just to wrap up a little bit, we've talked to you about how you can make beautiful inking solutions and how we're bringing that to the web. We've told you why intelligence is key in truly differentiating those experiences. And now I want Johan to show you one last time that we're really bringing it to more devices and more platforms. This is his demo working on a Galaxy Note right here. So, thank you. And if you're interested in being a co-engineering partner with us, please reach out to this alias. And please provide us your feedback. We have a survey here at the bottom of the page. We'd love to hear more about what you'd actually be interested in for your applications and any feedback you have on the presentation you've seen today. And we can take some questions right now, too.
Yep. Thanks.
Hey. Yeah.
It's okay.
Yeah.
Yeah, okay. So the question was, when we drew the shape and it came back as a perfect square, was there an API that we hit to get back the angles, let's say the rotation, or where the points were, and stuff like that? So the Ink Recognizer Cognitive Service understands a core set of polygons. The service is just like any other API. You can hit it separately with JSON, or you can use libraries like this Ink library, which we'll provide you. And the best part is the results, you can see the JSON structure on the Azure Cognitive Services website, but the result usually is what the perfect square would be, what the rotation angle would be on the page. Yeah, so you'd get the closest representation of what we can do. Yeah, and you can do a core set of polygons like parallelograms, diamonds, and stuff like that, and they'll all be different. You should definitely talk to us after this. We'll talk about adding your own shapes and making this as customizable as possible for you.
Thank you.
Yeah. Go ahead. Do you have a mic?
So with the objects on the canvas, say I draw a square, and then I want to draw a line to a square. Is there a way to say this line is interacting or touching that square? I think that would be really powerful.
Okay. Do you want to speak to it?
Yeah, sure. We don't, I don't think offer that today. We will offer you the ability to actually, recognize the shape itself. But, and I know that lines are coming, line recognition and error recognition is coming to the cognitive service soon. But that actual interaction with each other would be something that you probably have to do on the app side.
So is there any, sorry, that's another one. So from the object, like from the square, can I read out some kind of coordinate or something like that?
Mm-hmm.
Yeah, you can actually get hold of that.
Yeah.
So, okay.
Yeah, you'll be able to read out the coordinates on your canvas as well as the coordinates in a real life unit like millimeters or
That's
something
cool.
like that. Yeah. Yeah.
Okay.
You get access to it.
Yeah, thanks.
You also, for shapes that are not straightforward, like boxes, right? You do get bounding boxes around them that tell you which part of the screen, what four corners bound all of the ink in that content.
For the cognitive service, are you looking at anything in terms of recognizing more advanced styles of writing, like mathematical formula?
Yeah, definitely. That's something we're investigating, and that's definitely, we know that math as a form of input, it's really hard to type everything out with a keyboard today. Yeah, so, being able to recognize math is definitely something that's coming soon.
Hi there, one question. So the demo that you showed, especially about the form filling, that resonates with a lot of customer scenarios.
Yeah.
But most often, there is a real world scenario where occasionally connected kind of scenarios need to be supported, right? A lot of the web applications are also moving in that direction, but what about this one? Would this be available, especially the handwriting recognition, would it be available in occasionally connected scenarios if I don't have the internet connectivity right at that moment?
So that is really interesting because I can give you a kind of an answer to this. The ink recognizer is entirely... Okay, sorry. So the question was, with these form filling scenarios, oftentimes you don't have internet connectivity. So what happens then? Like, can I get recognition on that? In its current format, that demo used the ink recognizer cognitive service on a cloud as part of the cloud. So we hit an API to get that result back. Now, ideally, there are two ways to solve this. One is we save the ink itself, which our libraries have the ability to save ink in multiple formats, like JSON. So you could save the ink, and when you get connectivity, load it back and run the recognizer, right? As a future, we could explore having recognition natively, but this is a sneak peek into new beginnings for us as well. So
Yeah, it's on the roadmap for sure. That's definitely something.
yeah.
Hey, question about the original demo you did with the highlighting. So I was wondering if there would be a way to take that inking component and wrap it around some other components that you have. So wrap it around the text components so that when you highlight, you could actually get the text back from it as well. Is that something that you're looking into?
And that's the best part of web components, right? It's the fact that the web components spec allows you to extend these classes, and you're gonna get the opportunity to extend these if we don't go for that specific scenario as well. That's the best part, right? Anything you can dream of that you want these web components to do, they should be able to do. Good. Looks like we're out of time too. Thank you. Thanks for coming.
Thanks, everyone.
Have a good build.